Hi, today we are going to talk about direct variation. So, a direct variation is described by an equation or the form y equals kx equals the constant of variation. Let's solve the first example to see what is the relation between the slope and the constant of variation. Name the constant of variation for each equation, then find the slope of the line passed through each pair points. This line represents a variation, direct variation, because it passes through the origin, which is 0 and 0. Let's solve number A. We have y equals negative 4x, so k will be negative 4. The constant of variation equals negative 4. Let's use this formula to find the slope. M equals y2 minus y1 over x2 minus x1. Let's take the first point, which is negative 1 and 4. The second point is 0 and 0. So it would be 4 minus 0 over negative 1 minus 0, which is equal 4 over negative 1, which is negative 4. So the constant of variation is equal to slope. For number B, let's solve number B. It seems that the constant of variation is half because y equals half x is going to be equal half. And if we get m, which is y2 minus y1 over x2 minus x1, y2 is 3, so 3 minus 0 over 6 minus 0 also. So m would be equal 3 over 6, which is equal half. So it seems that constant variation equals the slope of the equation. Now let's see some points about direct variation. Direct variation equation are in the form y equal kx, where k not equal 0. The graph always passes through the origin. You should remember this. If the slope is greater than 0, slope is positive, then k should be greater than 0. If the slope is negative, then k would be less than 0. Let's take this example. Suppose y varies directly as x. So from the first statement, y varies directly as x, so we have to do equals kx. Then y equals 20, so we have to put 20 when equals 4. So 20 equals 4k. So to find the k, we have to divide by 4 by 4. So 20 divided 4 equals 5. So k equal 5, or the constant of variation is 5. So rewrite the equation using the constant of variation. The value of the constant of variation will be equal 5x. Then let's solve number A. He needs y when x equals 4. So we will substitute x by 4. So y will be equals 20. Number B, he needs x when y equals negative 20. So put y equal negative 20 equals 5x, then over 5 and over 5, then x will be equals negative 4. Inverse variation. If y varies inversely as x, if there is some non-zero constant k such that y equals k over x or xy equals k, where x and y of course not equal 0. In direct variation we make y equals kx, but in inverse variation y equals k over x. So let's solve this. Show whether each table or equation represents an inverse or direct variation. To see the difference between inverse and direct variation, we have to make at first multiply x times y. Then show it if it's gave same number, it will be constant. Multiplication will be constant, so it will be inverse direction because y x should be equal constant. So 1 times 16 equal 1 times 16 equals 16, and 2 times 8 equals 16. 4 times 4 equal 16. So the first one is direct variation where y x equals constant, which is 16. So it's equal constant. So it's inverse variation. Let's do the first one. 1 times 3 equal 3. But 2 times 6 not equal 3. So it's not the same. So it's not inverse variation. Let's see whether it's direct or not. So let's make division. 1 over 3. First one is 1 over 3. Second one, it's 2 over 6, which is also 1 over 3. Third one, 3 over 9, which is also 1 over 3. So this one is direct because y over x equals constant. or x over y equals 1 over 3. Here, x over y equals 1 over 3, so it's constant, it's direct. This one is direct variation. Let's see number C. Number C, x equals 2y. See, you know that the direct variation y equals kx, while inverse variation y equals k over x. Then we have to make it, sorry, x equals 2y. We need to see whether y equals kx or not. So you can make it over 2, then 1 over 2 x will be equals y. It's the same as y equals half x. So it is in the form of direct variation, so it will be direct variation. Let's see number D. Number D, 2xy equals 10. Let's make it over 2. So x equals 5. So xy equals constant. It's in the form of inverse variation. So this one will be inverse. I think it's very easy. Now let's see if we have ordered pairs like this. If x1, y1, and x2 are solution of an inverse variation, then x1, y1 equals x2, y2, or x1 over x2 equal y2 over y1. Let's make the first one. If y varies inversely, take care, it's inversely, so as x and y equals 4. So as you read inversely, you have to make it x1, y1 equals x2, y2. So then y equal 4 and x equals negative 8. Then in the first equation, we have negative 8 and 4 equals, let's see, x2. Find, he needs y2, so he needs y2 when x is negative 4. So he will put x equals negative 4, so negative 4. To solve this equation, we have to divide it by negative 4 and also the first one by negative 4. Take care, this will be cancelled, with the sign also will be cancelled. So here will be 8 equals 2, means that y2 equals 8. This is the inverse variation. As a summary of the lesson, let's make a comparison between direct and inverse variation. That direct variation in the form y equals kx, where k is a constant of variation and it represented with a straight line. If k is greater than 0, this straight line will have positive slope, then it will be like the first shape, and if k less than 0, it will be like the second shape. Also, we can read as y varies directly as x, or the ratio y over x will be constant, or x1 y1 equals x2 y2. Also, we can represent it as x1 over y1 equals x2 over y2. In the inverse variation, maybe as the shape, the first or second shape, where k is positive in the first shape and k negative in the second shape. Then y will be constant over x, or x1 y1 equals x2 y2, or another solution, x1 over x2 equals y2 over y1. And we read it as y varies inversely as x, or the product of x, y should be constant. Thank you for watching. Please subscribe. Bye bye.